we are going to discuss about the topic embedded system design concepts. This belongs to the fourth module of your syllabus, and we are referring the textbook by name Introduction to Embedded System. The author name is Shibu KV. So this is basically, it deals with the fundamentals, and also it gives you the glimpse of how exactly embedded system can be designed. Okay, the uh, contents of this one, or we can also call that as the objectives of this particular module, is basically deals with characteristics and quality attributes is the first one. Second one, operational and non-operational quality attributes, one of the very important topic of this particular module. And also we come across various embedded system. Basically they are categorized as domain specific and application specific. In this topic, we take some few examples of domain specific and also few examples of application specific, and we are going to explain the embedded system based on those type of categories. And one of the very important topic of this, or one of the important objective of this particular module, is how exactly a hardware and software can be designed together, put together to develop one very good embedded system. And we also deals with the programming model of this hardware software co-design. But in this one very important is the UML is not been discussed. UML is not required. Similarly, then one more topic is embedded firmware design and development. So hardware software co-design also we are going to discuss, and also embedded firmware we are going to discuss, except the C language. We don't discuss the C language here, but we are going to discuss about the embedded firmware design and development. Moving ahead, first, the first thing is the characteristics of the embedded system and also quality attributes of the embedded system. Let us look into what are the characteristics. Basically, an embedded system possesses some specific characteristics. Every embedded system is having a unique characteristics. So we cannot come to a conclusion that all the embedded systems are having the same specific characteristics. Each and every embedded system which is available in the current scenario, they have their own unique characteristics. So some of the general important characteristics of the embedded systems are, one is application and domain specific, means some embedded systems are application specific, some embedded systems are domain specific. Similarly, reactive and real time. This is means the embedded system can be categorized as some of the embedded systems are reactive, means based on the event or based on the input they are going to react. Some of them are real time. So efficiency should be very important with respect to real time embedded systems itself. We'll look into. Okay. Similarly, operates in harsh environment. One of the very important characteristics of the embedded system is, and basically the why exactly embedded system has been evolved is where the manual intervention cannot be there, or where the human cannot go and operate that one. At that time, we can develop some embedded system where they can go to harsh environment, like environmental conditions. Severe environmental conditions will be there, where we cannot manually we cannot enter. So at that time, we can use the embedded system. And distributed operations is one very important characteristics of the embedded system. That means if you look into the very big embedded systems like multiple industry, in an industry, multiple machines are connected, they need to operate. So the embedded system is being distributed to multiple machines itself. So that is also one of the important character of the embedded system. And small size and weight. Basically, most of the embedded system what we're having in the world, globally they are used. It should be handy. We cannot have a very big embedded system where we cannot move them properly. Similarly, it should have a proper weight. It should not have a too much weight where it cannot be shifted, it cannot be carried. So we have to carry them easily. So that is also one of the important characters whenever we are going to design the embedded system. Power consumption is one more characteristics of the embedded system. Most of the embedded system what we are having currently, they all work with the battery power. Okay, very few are means our industries embedded system, they may require very high power, but most of the handheld gadgets, handheld embedded system, they work with the battery power. So power concern is the one of the most important characteristics of the embedded system. Let us see how exactly application specific and domain specific embedded system comes into. Each embedded system has certain functions to perform and they are developed in such a manner to do the intended function only. That is what the definition of the embedded system. Embedded system is the combination of the hardware and software which is meant to perform a specific task. Okay, they cannot be used for any other purpose. So we have so many embedded systems, they are designed and developed and released into the market to perform a specific task itself. One of the example is the micro oven, where the micro oven cannot be replaced with an air conditioners, okay, embedded control unit. We have an embedded control unit in micro oven that cannot be replaced by the AC embedded control unit itself. The embedded control unit for the AC is totally different and embedded control unit for the micro oven is totally different itself. One is the cooling embedded system, other is the heating embedded system. They have a specific purpose, they are specifically designed over that. Similarly, an embedded control unit developed for a particular domain, say telecom domain, cannot be replaced with any other control unit designed for server another domain to serve another domain like consumer electronics. We have an embedded system for telecom domain, that cannot be replaced by the consumer electronics control unit itself. So application specific is it is meant for a particular application. An embedded system which is developed for the telecom domain means it should be used for telecom domain only. We cannot use some other embedded system to operate that one. That is the application specific, we'll call that one. And also domain specific. Moving ahead with the second characteristics, reactive and real time. Embedded systems are in constant interaction with the real world through sensors and user-defined input devices which are connected to the input port of the system. Some of the embedded systems, they basically work with the sensors, or most of the embedded systems, they work with the sensors, where the sensors are capturing the data frequently or regularly, and based on the data, whatever it is acquired, it performs. Any changes happening in the real world, which is called an event, are captured by the sensors or input devices in real time, and the control algorithm running inside the unit reacts in a designed manner to bring the control output variable to the desired level. See, example is a temperature sensor. So temperature keep varying over there. So in a single day, if you consider temperature from morning till evening, it keeps changing. So the sensor which is connected to the embedded system will be capturing the temperature, and based on the temperature, the embedded system will perform and it's going to generate some activity and it's going to give the desired output. Embedded systems produce changes in output in response to changes in the input. That is what the example I have given. So they are generally referred as the reactive. Reactive means if input changes, output changes. That is what we are going to say. Real-time systems. There is another type of the embedded system. Real-time system operation means the timing behavior of the system should be deterministic. Timing behavior. The system should respond to request or task in a known amount of time. Even I can say, based on the time, I should get the response. Most of the time, the satellites we can call, they're working with the real-time operations, because I need to check morning 6 o'clock, I need to get the reading. Then after 9 o'clock, I need to get the reading. Then 12 o'clock, I should get the reading. Means time-based operation. So based on the time, some real-time data, real-time operations is going to work. A real-time system should not miss any deadlines for task or operation. One of the important feature of this particular characteristics is it should not miss any deadlines. If it is 6 o'clock means it should get exactly at 6 o'clock. It should not mismatch that. We should not miss. It is not necessary that all embedded systems should be in real time in operations. Embedded applications are systems which are mission critical, like flight control system, ABS, are one of the best example for your real-time system. Anti-lock braking system, okay, and flight controlling system. Flight control should have a 100% efficiency, so it should work real time itself. Third characteristics. So embedded system operates in harsh environment. The environment in which the embedded system developed may be a dusty one, or a high temperature zone or an area subject to vibrations and shocks. That's what I told you. Where the human intervention or where the human being cannot enter into that particular area, particular environment, embedded scan system can be used over there. Systems placed in such areas should be capable to withstand all these adverse operation conditions. There may be temperature may vary exponentially, temperature may go down, and the temperature may go up also. So your embedded system should work in both the severe conditions. Okay, the design should take care of the operating conditions of the area where the system is going to implement. So operating conditions also is very, very important. If the system needs to be deployed in a high temperature zone, then all the components used in the system should be of high temperature grade only. See, if I am developing an embedded system where it need to work inside the furnace, so where the furnace is having high temperature, the components what we are using should be working in that high temperature only. Also, proper shock absorptions techniques, especially in your vehicles, where the vehicles is running with very high speed, all the vibrations are taken care. So all these embedded system which is incorporated in that particular vehicle should also sustain that shock absorption. Okay, should be provided to system which are going to be commissioned in place subject to a high shock. Power supply fluctuation also one of the important feature where there may be a lot of fluctuation with respect to power consumption, corrosion, and component aging. All these things should be taken care whenever you are going for the designing the embedded system. Fourth characteristics, distributed. That is, the operations of a single embedded system is being distributed. The term distributed means that the embedded system may be a part of a larger system. Many number of such distributed embedded systems form a single large embedded control unit. Example is a automatic vending machine. Automatic vending machine, or furthermore, you can call ATM. Okay, automatic teller machine we will call it automatic teller machine, where operations are local, operations are going to server, operations are going to the database. Some operations are kept in the database, some operations are kept in the server, some operations are kept in the ATM machine system. So it needs to read a card reader, it should validate the card, and if the card is valid, then it should go to the database and check it out whether it is having a sufficient amount in the account. Balance need to be checked, and then it should check for the what exactly you want from the vending machine, that particular ingredients should be available, should be in the vending machine. All those things need to be taken care. So the operations are distributed such a way that when some operations are local, some operations are connected to internet. Okay, each of them are independent embedded units, but they work together to perform the overall vending function. Okay, so that is distributed. ATM, automatic teller machine. It contains a card reader embedded unit responsible for reading and validating the user's ATM card, transaction unit for performing the transaction, a currency counter for dispatching the or vending the currency to the authorized person, and a printer unit for printing the transaction details. See how many operations are there in the ATM machine itself. We need to have a printer, we need to have a counting machine, it has to count the proper currency notes, and it should also select the different types of currency notes. Okay, and you should also check the balance, it should also validate the card, it should also validate the pin. So many operations are there in the automatic teller machine, so all are distributed. We can visualize these as independent embedded system, but they work together to achieve a common goal. Another typical example of the distributed embedded system is the supervisory control and data acquisition, that is CADA system used to control an instrumentation application which contains physically distributed individual embedded control unit connected to a supervisory module. Okay, so this is also one of the best examples, CADA tool, where electrical engineers are very much popular about this CADA tool itself. Fifth one, small weight and size. Product aesthetics is an important factor in choosing a product. See, whenever you are selecting the product, you should also look for its physical appearance and how much it's going to weight. All those things, it should be satisfying customer. When you plan to buy a new mobile phone, you may make a comparative study on the pros and cons of the product available in the everything will be considered. So we should know how much size is there, what is the width, height, what is the weight of that one, and finally what is the cost also. People believe in the phrase small is beautiful. Moreover, it is convenient to handle a compact device than a bulky product. In embedded domain, also compactness is a significant deciding factor. Most of the application demand small sized and low weight products. See, whenever I'm having a smartwatch, I maybe having a handheld gadgets, gaming device. So it should be handy. It should not be too big to carry. It should not be too big to operate also. So size is very important and weight also very important. It should be nominal weight. We should have that normal weight where even a kid can easily carry that medicine. So small is beautiful, small is comfortable. So this is the fifth character where the embedded system has to be considered. Power concern and the last characteristics of the embedded system. Power management is another important factor that needs to be considered in designing embedded system. Embedded systems should be designed in such a way that as to minimize the heat dissipation by the system. If it dissipates the heat, it consumes more power, and power consumption also is an important factor over there. The product of high amount of heat demands cooling requirement like cooling fans, which in turn occupies additional space and make the system bulky. Since the design according to the select the design according to the low power components like low dropout regulators and controllers and processors with power saving modes. Also, power management is a critical constraint in battery operated applications. See, some embedded systems are battery operated, where if it is battery operated, if it is placed in a remote location where it cannot get the power, so we should see to that one power consumption should be very, very less so that it lasts for the longer duration. The more the power consumption, the less is the battery life. Obviously, even a mobile, okay, it should consume less power. During the idle stage, the power consumption should be as minimum as possible. During the active mode, power consumption should be normal. Okay, it should not consume more power itself. So these are all the 6 different common characteristics of any embedded system which is going to be designed and which is need to be released in the market itself. So let us move ahead.